Alright, welcome to video 3. In the last lesson we left off after we graphed the y-intercept, and we told you in video 3 we were going to take a look at what we do next, and that's exactly what we're going to do. So we briefly mentioned the slope in video 2. Right now we are going to go ahead and talk a little bit more about it. Remember in our slope-intercept form, y equals mx plus b, we said that m is going to be our slope. Now, we have a lot of different ways to talk about slope. You'll commonly heard it referred to as rise over run. What that means is we're going to be comparing how much we are changing with our y values and how much we are changing with our x values. Remember, y is going to be our change up and down, and our change in x is going to be going left to right. The slope is going to tell us how the graph changes and is located with the x variable. It is always attached to the x variable. The x is not part of the slope. So for example, if you have something like y equals 3x plus b, your slope would be 3. A lot of people for some reason like to attach that x to it. It's just going to be the coefficient. Now, as we were saying, slope can be referred to and interpreted as the difference in rise, which is your y values, divided by the difference in the run, which is your x values. Now, when we are graphing, we're going to want to put this in fraction form. If we have a decimal, it's going to be very hard for us to graph with that slope. But remember, your calculators can convert things from decimals to fractions. And if you need help with that, let us know. So as I said, we talk about slope. We call it several different things. You may hear it called as slope, the rate of change, the average rate of change, the rate of increasing or decreasing. We might talk about the steepness of a graph, its cost per unit if we're talking about a word problem. We also might refer to it in the formula form. And just a note, this is on your formula sheet right here. So make sure that if you're having trouble remembering what your slope formula is, that you go back and look at that. But what it's going to be is y2 minus y1 over x2 minus x1. And we'll look at that in a little bit about how we'd actually plug into that equation. And sometimes in your word problems, you might also see it referred to as your speed. Alright, so we're looking at the same example from our y-intercept example in example 2. Remember that our general form, and let me switch back to a pen since I'm trying to use a highlighter here. Alright, y equals mx plus b. So we had said in the last video, our y-intercept was a 4. So I'm just going to go ahead and put a dot at that 4. Remember, that's just where we left off from the last video. If you are having trouble where we got that, go back, review video 2, and then come right back here. Alright, our slope is going to be negative 2/3. Now, to understand what we have to do with that, we need to talk about some of the rules for slope. Now, if our top number, it's always going to tell us up and down because that goes with our y values. If the number is positive, we are going to go up, and if the number is negative, we're going to go down. The bottom number is going to tell us whether we're going left or right. If the bottom number is positive, we're going to move to the right, and if the bottom number is negative, we move to the left. Now, the whole negative thing can be a little bit tricky if you have a negative number here. We can write this negative 2/3 in two different ways. We can write it as negative 2 over 3, or we can write it as 2 over negative 3. And we'll go ahead and look at this. Either way we do it, we're going to end up with the same line. The important thing is you do not want to take the negative and put it with both of them. And the reason that doesn't work is if you think back to our arithmetic rules, when you divide negative by a negative, you're going to get a positive. Now, I'm just going to go ahead and assume that we put it on the top first. So what this would mean, since it's a negative 2, is I would go down 2, and then my bottom number is a positive 3. So I would go right 3. So I'm going to just count the blocks, 1, 2, and I'm going to count over 1, 2, 3. I'm going to put a dot. I'm going to repeat this process. I'm going to go down 2 and over 3, and I'm going to put a dot. Now, as you can see, I ran out of room on my graph. The other way we can do, if we were running out of room, is reverse it. Instead of going down 2 and right 3, we can do the opposite of both of them, and that would match with our negative being on the bottom. We can go up 2 and left 1, 2, 3. Now the very last thing that we do when we graph is to go ahead and play connect the dots. We want to connect using a ruler preferably, because that's going to be our best way of getting a straight line. And as you'll find out in later lessons, our accuracy is going to be important. We want to make sure that we have the line going where it's supposed to be doing. And notice that when we graph these lines, we always want to have arrows on both ends. The reason that we have arrows on both ends is because these lines go on forever. We can only represent so much space on these graphs. Instead of trying to draw a graph that's big enough to show every single possible combination that makes this equation work, we use those arrows to indicate that these go on for an infinite amount of time. Alright, we do have a little memory trick that can help us with some of our slopes. Anytime that you are going to have a positive slope, anytime that that fraction or number in front of there is a positive number, it's going to look like it is going uphill. Alright, and that can be represented in Mr. Slope Guy in the eyeball over here. If we have a line that has a negative slope, it is going to be going downhill, and that can be represented in the other eye over here. Now, every now and then we might have a slope of 0, and what that is going to do is that is going to make the line horizontal, and that is going to be the mouth of Mr. Slope Guy. It's going to be like this, just a straight line horizontally. And then finally we may have an occasion where we have no slope or an undefined slope, and that's going to be a vertical line, and it's going to go straight up and down, and that's going to be the nose. Now, just to go over this a little bit more for those two situations, we'll talk about them later, but if your slope is 0, you're always going to have y equals some sort of number, and it's going to be that vertical line across. Anytime that you have an undefined slope, it's going to be x equals a number, and that's going to be when it's up and down. Alright, so you guys go ahead and give these u-tris a problem. We're going to combine y-intercept and slope, and we'll see you guys in the next video.